And hi, Professor Chen. This is my first video for this week, and this video is about question 1. This question is: x and y have a joint density function fxy like this, 1 plus xy divided by a, and the absolute value of x is less than 1, and absolute value of y is less than 1 too. The fxy is equal to 0 otherwise. And the first question is: find the a so that the above defined is value joint density function. And if xy is a value joint density function, when we integrate fxy from a negative infinity to the positive infinity, then we can get a 1 here. And by applying the equation of this, it's easy to find the value of a is equal to 4. And the second question is: are x, y are uncorrelated? And in order to solve this question, we need to focus on the value of c, where c is equal to exy minus ex multiplied ey. And if c equal to 0, then xy are uncorrelated. If c is not 0, then xy are not uncorrelated. And in order to calculate the c, we need to calculate every part of this equation here. And just based on the definition of ex and exy here, so it's easy to find that c is not equal to 0, so xy are not uncorrelated. And the third question is: are xy independent? We already know that xy are not uncorrelated from the question 2, so it's easy to know that xy are not independent here. So xy are not independent. And the fourth question is: find the joint density function of x squared and y squared. And we can just write the condition like this: z equal to x squared and w equal to y squared. And in order to find the joint density function of x squared and y squared, we just need to find the fzw here to be the answer. And based on what we have learned from the lecture, first we need to calculate the jxy here, and then we need to find the root of these two equations here, which is like this. And jxy is equal to 4 multiply x and then multiply y. And then we just need to apply this equation here to find fzw, and finally we calculate the fzw is equal to this. And we already know that absolute value of x is less than 1, and absolute value of y is also less than 1. So the range of z should be 0 to 1, and the range of w is also should be 0 to 1, and otherwise fzw is equal to 0. So the answer is this. And the fifth question is: prove or disprove that x and y are independent. And we already know the fzw here, which is the joint density function of x squared and y squared here, like this. And we can find that the fzw is equal to this, and fzw is a product of the function of z and the function of w, and the absolute value of x is less than 1, and absolute value of y is less than 1, which means they have no relationship of their range. So they are independent because fzw is product of function of z and function of w, and there's no relationship between the range of x and the range of y here. So they are independent. That's all. Thank you.